beautiful, isn't it? It's been the object of fascination for mankind and animals from whenever we could see. I'm sure you have a lot of questions about the moon. Questions like, where did it come from? Why doesn't it fall into the earth? Why does it keep changing shape through the month? Or why does it have so many holes? Holes that make it look like it's made of cheese. How I wish I could just stand on the moon and see what it looked like up close.
Well, today's your lucky day.
What? You can talk?
Yup. Just for today. You want to see what I look like up close? No problem. Hop on. So, how does it feel on the moon?
A little weird, actually. So the first thing that you notice when you land on the moon is the complete lack of air. That helped a lot. So this is because the moon is a lot smaller than the Earth. In fact, it's about 50 times smaller, which means you could fit around 50 moons into the Earth. And because it's a lot smaller, the gravity on the moon is a lot weaker. And this weak gravity is not strong enough to hold constantly moving air molecules. So any gas on the moon just escapes. Also, the lack of air leads to extreme temperatures. For example, the side of the moon that's facing the sun reaches temperatures of around 150 degrees Celsius. And similarly, the side that's facing away from the sun reaches temperatures of minus 150 degrees Celsius. You know what? This is getting quite uncomfortable. Let's assume that I don't need it. The other thing is, because of the weaker gravity, your weight on the moon is much lesser. In fact, your weight will be about 1/6 your weight on Earth. This means you can jump really high. Wait a minute. You can actually slam dunk a basketball into a basket that's 50 feet high.
By the way, why do I look like cheese?
Well, that's because of all the craters on your surface. The moon has a lot of these depressions that you can see. These are just the small ones. Let's go find a big one. This one, for example, is quite huge. It has a diameter of 40 kilometers. These craters were formed when asteroids and meteorites collided with the moon. These collisions happened many, many years ago, when the solar system was extremely young. The moon is also quite far from the Earth. It's about 4 lakh kilometers from the Earth. To give you an idea, if you drove a car at the speed of 100 kilometers an hour from the Earth to the moon, you would reach in about 170 days.
Let's see if you can answer this one. If I don't give off any light like the sun, how come you can see me from the Earth?
Now, that's because you reflect the light from the sun. Now, during the night time, the sun produces light, and this light bounces off the moon and then reaches Earth. That's why we can see the moon. If the sun was somehow switched off, then the moon will be invisible. Let's take an example. Have you seen one of those reflectors on the road? They don't produce light of their own. They reflect light from headlights. That's why we can see them. So the sun plays the role of the headlights, and the moon plays the role of the reflector. Did you know that only one side of the moon always faces the Earth? For example, let's say that my head is the Earth, and the moon is going around the Earth like this. As you see, only one side faces me, and the other side never faces me. So this is because the time period of rotation and time period of revolution is exactly the same. Or in other words, the time the moon takes to go around the Earth is equal to the time it takes to complete one rotation about its own axis, which is around 27.3 days. Now I know this might be a little complicated, so let's do a simple experiment to understand. Well, it feels good to be back on Earth. So this is the experiment. So let's say that this apple over here is our moon, and we have the Earth on this table. Now, what exactly will the moon do? Now we know that the moon goes around the Earth, and I also told you that it does it in a peculiar way. So it does it in such a way that only one side of the moon always faces the Earth, this side. And I told you that this is because the time period of revolution is equal to its time period of rotation. To check that, let's measure its time period of revolution using a timer. Now let's see how long it takes to complete one rotation about its own axis. So therefore, we see that only one side facing the Earth is a result of the fact that its time period of revolution is equal to its time period of rotation.
Hey, I have a question. How do I keep changing shape constantly? Sometimes I'm a curved shape. Sometimes I'm complete. How is that happening?
Well, that's a nice question. So when I was a young kid, I used to think that this is because there was some giant space monster that was eating the moon bite by bite, and somehow the moon used to grow back by itself. Well, the truth is, there is no such space monster. It happens because the side of the moon that's facing the Earth gets less lit or more lit based on its position as it moves around the Earth. You know what? Let's do another experiment to understand this. Now, this is the experiment. Now, I want you to imagine that I am floating somewhere in space, and that bright light over there is the sun. This white ball is the moon, and I am the Earth. I repeat, the bright light is the sun, this white ball is the moon, and I am the Earth. And let's neglect the rotation and the revolution of the Earth. We know the Earth rotates about its axis and it goes around the sun, but let's neglect that for now. It's not important. What is important though is the movement of the moon around the Earth. So what does the moon do? The moon also rotates and revolves in such a way that only one side faces the Earth all the time. For example, it does something like this. So if this is the moon and I am the Earth, it goes around. It goes around the Earth like this. But the thing is, it's not exactly like this. What I mean is that the plane of revolution of the moon is slightly tilted. What that basically looks like is like this. So the moon moves around like that. So as you saw, the plane of revolution is slightly tilted like this. Now because of this, there are a lot of interesting things that happen. We'll go into that later. Now, let's look at what the moon will look like as it goes around the Earth from the Earth's point of view. Or in other words, what the moon will look like as it goes around from my point of view. Let's say this is the first position in its cycle. As you see, it's just in between the Earth and the moon, so therefore you can't really see it from the Earth, right? Because the side of the moon that's lit is facing the other way. So it's just impossible to see the moon when it's like this. Okay? But then the moon starts moving, right? It starts revolving around the Earth. So in about 3 days or so, it comes to this position. Now you see that we can see a part of the moon, right? A part of the side that's facing us is lit, a very small portion, and it's curved like this. Now, this phase is called the crescent moon. It's very common, very popular. More specifically, it's the waxing crescent. Now, of course, you can ask me why it's called the waxing crescent. I'll explain that a little later. But understand that this is the crescent moon. Okay? Now, the moon starts moving again, or it continues to move in its cycle. And in about 3 days' time, it reaches this portion. And this phase is called the first quarter, because the moon has completed approximately about a quarter of its cycle. And what you see is just that half of the side that's facing us is lit, exactly half, right? Okay, and the moon keeps moving again. Now, this phase is called the waxing gibbous. In this phase, you see that about 3/4 of the side that's facing us is lit, or a little more than half of the side that's facing us is lit. Now, in this position, we see probably the most popular phase of them all, maybe even the most beautiful. You see that the side that's facing us is completely lit, and this phase is called the full moon. In this position, the moon has completed exactly half of its cycle, so now it starts coming back towards the sun. And in about 3 days or so, this phase is what it reaches, and this is called the waning gibbous. Now again, it's a gibbous because about 3/4 of the side that's facing us is lit. But it's a waning gibbous because it's on the other side.
अगर आपको पार्ट 4 में आएगा, अगर मेरे चैनल सब्सक्राइब कर दीजिए। उसके बाद आइए और लाइक करके करना भी मत भूलिए। और अगर आपको किसी और टाइप के लिए भी वीडियो चाहिए तो बस मुझे कमेंट कर देना, मैथ्स या साइंस के बारे में।